Hello again, everyone. We are going to start chapter 5, and in this chapter, we will talk about the skeletal system. Skeletal system is made out of different subtypes of connective tissues. We have the bone, these are the hard elements of the skeleton. We have the ligaments, these are dense fibrous connective tissue which are attaching bones to other bones. And we have the cartilage. And the cartilage, this is a specialized connective tissue, as we talked last time. They are made of fibers of collagen and elastic in a gel-like ground substance. We said these are tough yet flexible type of connective tissue. So these are going to cushion the vertebra and they are going to reduce the friction between the bones. Now, when we say skeletal system, the first thing comes to our mind is the bones. The bones are the hard materials, and they made out mainly of non-living extracellular crystals of calcium minerals. Now, the bone is not only the crystals. There are different types of cells as well, and there are different types of fibers. And for example, these cells involve in bone formation and remodeling. Now, the overall functions of the bone can be summarized as support, protection, movement, blood cell formation, mineral storage, mainly for calcium and phosphate. So these are different types of or different functions performed by the same organ. Now, in the bone tissue itself, we can have two types or two forms of bones based on their shape. We have something called compact bone and we have the spongy bone. Compact bone, it forms the shaft and the ends and it contains marrow space. It contains a marrow space. So inside it, there is a hollow, there is a tunnel. And that tunnel is filled in adults in yellow bone marrow, which is mostly fat. Okay? Now, that the compact bone, for example, if you are looking at any bone from its outer surface, what you are looking at is a compact bone. That smooth surface of the bone is made out of compact bone. The other type is the spongy bone, and these spongy bone, think of them as structures that extend in different directions, and they leave spaces between each other. So they are not. If this is a compact bone, there is no space between the component of the bone. With the spongy bone, it has these spaces, and technically the name is coming from its appearance. It will appear as a sponge because of so much spaces between them. And these are technically we are calling them trabeculae, and they form like lattice-like support, and these spaces between them contain red bone marrow, which is technically is the blood. Along with that, we have the cells. Now, these cells, the osteoblasts, the osteocytes, and the osteoclasts, technically form both types of bone, of the bones. These cells, we can find them in the spongy bone, and we will find them, of course, also in the compact bone. So, no difference in cell type between the two types of bones. The difference is how the bone itself, how the hard material is arranged. Is it arranged like these spaces and leaving these spaces between each other, or they are like just dense and compact? Now, the main system for this arrangement is called the osteon or the Havarian system, which is cellular arrangement. We will see it when we cover the image. And in general, the bones are protected by a membrane, by a connective tissue covering called the periosteum. So, as you can see here, the outer surface the outer surface of the bone is made out of compact bone, whereas the inner parts, these are spongy bone. So the compact bone would form the ends, the epiphyses, the ends of the bone, and the shaft, the middle part. And in the center, there is the bone marrow. There is this hollow space that will form the bone marrow or the central cavity, which is usually is filled with yellow bone marrow. Whereas the spongy bone, this is how they will appear. As you can see, there are plenty of spaces, and this will give the sponge shape, and that is the name coming from. Whereas here, as you can see, there is no spaces between the bone layers. This is the osteon, and the osteon is a circular arrangement of the bone, and technically we'll find it only in compact bone, only in compact bone. Okay, so this is that overall structure of the bone. Now, the bones usually form joints, and therefore they need to be attached to each other. Ligaments are what hold the bones together. Ligaments are usually made, or in many cases they are made of dense fibrous connective tissue, which is very tough connective tissue. And that connective tissue would provide, or these ligaments in general, would provide strength in joint, yet they will enable the movement. So the bones cannot be separated from each other. Okay, they are attached with these ligaments, but yet these bones can move in different directions and stay attached to each other. Now, cartilage is a supporting tissue that is tough under pressure. Tough under pressure. Think of bones might break under high pressure, but cartilage or cartilages in general are usually fine. They are flexible, and in our body we have three different types of cartilage. We have the fibrocartilage, which is forming the intervertebral discs between the vertebra, and also it will form the menisces in the knee joints. Think of them like the knee disc. And the second type is called hyaline cartilage. These are forms embryonic structures. So our bone mainly is when during fetal development, the initial structure of the bone was made of hyaline cartilage, and then it got replaced by bone. Hyaline cartilage would cover and protect ends of long bones and joints, providing protection and reduce friction. And the last type of cartilage is elastic cartilage. Elastic cartilage is very flexible. We can find it, for example, in the outer ear and in our epiglottis. So these are the three different types of cartilages in our body. Now let's talk about the cells. The cells, whether they are in the cartilage or in the bone, for example, in the cartilage, we have the chondroblast. These are the cartilage forming cells. Osteoblast, these are young bone forming cells. Osteocytes, these are the mature bone cells. So osteoblast will develop into osteocytes, and then we have the osteoclast, which are the bone dissolving cells. In general, all of these cells have different functions in maintaining bone. We are not going to see the details of their function, just understand that they have a general function in maintaining bone. Now, for bone development, it starts during fetal development. In the beginning, cartilage forms the backbone of the skeletal system, and around week 9 of pregnancy, bones start to form and gradually replace cartilage. After birth and through adolescence, bone continues to grow, and that growth is happening at something called a growth plate. Now, there are other effects of hormones that would promote growth and bone lengthening and bone formation. For example, in the pre-adolescence, we have the growth hormone. In early adolescence, we have estrogen and testosterone. Estrogen in females, testosterone in males. They will stimulate bone lengthening. And even in late adolescence, we still have the effects of these hormones, estrogen and testosterone. They will cause replacement of the cartilage growth plates with bones. So what are we talking about? This is in fetus during the first 9 months. So this is around week 9. Okay, as you can see, all of it is cartilage, and from that moment the small portion of bones would start to develop, and till adulthood, or technically even till adolescence, bone will keep replacing cartilage. So cartilage at adolescence, we will have it at the bone ends, in the growth plate, and that's it. Whereas starting with entire cartilage plate. So from here, from this area or from this stage, all the way to this stage, we are replacing cartilage with bone. Or sorry, we are replacing bone with cartilage. This is the growth plate. And here, this is the space or the area responsible for lengthening the bone, or growing in length of the bone. This video would show you some animation about how the bone is formed, so please watch it. Now, with bone forms, it does not mean that it is stable. No, bone undergoes remodeling and repair during lifetime. So even if we are 60, 70 and we are healthy, then our bone is still undergoing remodeling and repair. For remodeling, these are changes in shape, size, and strength. For example, exercising, especially weight-bearing exercising, would increase the overall bone mass and strength, and also they will change the shape of the bone. And bone homeostasis depends on the balance of osteoblast and osteoclast activity, because one is going to form bone and the other one is going to dissolve bone. So these will dissolve the old bone. If you want to think of it like this, these will dissolve the old bone, these will form a new bone. So if these are outer or super active, then we are losing the bone mass. If these are super active and these are kind of lazy, then we will have very heavy, very thick bone, which is not really healthy. And in case we have much of osteoclast activity, that will develop osteoporosis, which is the loss of bone mass due to prolonged imbalance of osteoblast and osteoclast. Technically, these will eat the bone, whereas these are not fast enough to replace or to produce a new bone. Okay, so that is when osteoporosis would happen. And as we said, bone will continue to change in shape, size, and strength, and that is constant remodeling. Because whenever we have bone deposited, usually bone is deposited in areas of high compressive stress, and usually bone is reabsorbed in areas of low compressive stress. And as we said, weight-bearing exercise would increase the overall bone mass and strength. See, for example, this is the femur. So if there is an excessive force from the body weight, then, and that force is unequally distributed, then we will add a new bone into this area and reduce the bone here till both sides will have equal bearing of weight. and that is the ideal situation. Now, bones also, or bone cells, are regulated by hormones. And we have two types of hormones. We have the parathyroid hormone, or the PTH. Now, PTH is secreted when there is low calcium levels. So PTH secretion would lead to increase blood calcium levels. PTH, again, PTH, or no, you know what, I'll draw it in another way. So PTH, if there is low calcium levels, then PTH would be secreted, released. PTH technically would activate the osteoclast cells, and these osteoclast cells will dissolve the bone and release calcium back into the blood. Okay, so PTH, maybe it's better to write it on here. So we have a homeostatic level of calcium, right? We don't want to go beneath this level. So for some reason, sometimes this calcium is low in the blood. What will happen? The parathyroid gland will sense the low calcium level and release parathyroid hormone. Parathyroid hormone will go to the bones and technically to the osteoclast, and these cells will dissolve the bone and release calcium back into blood, which will lead to increased calcium levels in the blood. Okay, so this is how the parathyroid hormone works. However, we have the other hormone, which is calcitonin. Calcitonin would secretion increase when we have high calcium levels. So calcitonin would work in opposite to the parathyroid. So how calcitonin is working? Say for example, if we have high calcium levels, then this time the thyroid gland will sense the high calcium levels. The thyroid gland will release the calcitonin. Calcitonin will go to the bones, and specifically it will go to the osteoblast and ask them to make a new bone. A new bone requires calcium, and that calcium would be taken from blood, which will lead to low calcium levels. So we started with high calcium levels and we ended up with low calcium levels through this calcitonin. Whereas, Whereas with the parathyroid hormone, we started with low calcium and we ended up with high calcium. So these two mechanisms are examples of how hormones regulating bone cells. Bones undergo repair whenever there is bone fracture, whereas these are the mechanisms of how bones repair themselves. So we will have the bone fracture, then blood cells would come to the site of fracture. The fibroblast, these are the mother cells, they are going to move to the area to begin the repair process. Then the tough fibrocartilage callus is formed at the site of fracture by the chondroblast. Then osteoclast remove the damaged bone and remnant of the hematoma. Then the osteoblast deposit a new bone in area of fracture, and the repair process takes from weeks to months, depending on the age, depending on the diet, and depending on the site of injury.
The repair.
So this is an animation on the bone repairs. I will stop here. Please watch it and post your questions in the forum, or your questions or videos or comments in the forum. See if your classmate have any question, and we will come back.